Assalamu alaikum warahmatullahi wabarakatuh. In this video, we will learn what is union and intersection of two sets, what are disjoint sets. We will solve word problems based on sets from practice set 1.4 using the formula number of element in A union B. Number of element in A union B is equal to number of element in set A plus number of element in set B minus number of element in set A intersection B. Chapter set. Example: if set A is equal to 1, 2, 3, 4, 5, 6, 7, 8 and set B is equal to 6, 7, 8, 9, 10. The Venn diagram of both the set A and set B. So set A contains 1, 2, 3, 4, 5, 6, 7, 8. Set A contains 1 to 8 number. Then set B contains 6, 7, 8, 9 and 10. Now the union of these two sets. What do you mean by union? Union of two sets. Union means all elements. All elements of set A and B are contained in the union. So here set A union B. This is symbol of union. Write A union B as is equal to all the elements of set A and set B. Means the element of set A, that is 1 to 8, as well as this element of set B 6 to 10. But there should not be repetition of the common element. We should write the elements once. So A union means all elements of set A and B, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now the intersection. What do you mean by intersection? Intersection means intersection of two sets, that is A and B, means the common element of A and B. Intersection means common elements. The elements which are common, they will come in the intersection part. So this portion is the common part in set A as well as set B. So A intersection B is equal to common element, or you can see that in the Venn diagram. This is the Venn diagram. The common element in both the sets are 6, 7 and 8. So here you can see here we said A 6 is there, B also 6, and A and B both has this 6, 7, 8 number. So intersection means common element are 6, 7 and 8. Now the number of elements in set A union B is written as the number of elements in set A union B, that is N A union B is equal to number of elements, total elements in the set A union B are 10. The number of elements in set A intersection B, A intersection B are 3, and number of element in A is written as the number of element in A is Na is equal to 8, and number of element in set B is written as Nb, number of element in B, which is equal to 1, 2, 3, 4, 5 elements. Now what are disjoint sets? If set A is equal to 1, 2, 3, 4, 5 and set B is equal to 6, 7, 8, 9, 10, then you can see by therefore Venn diagram, set A contains the elements 1, 2, 3, 4 and 5, and set B contains the elements 6, 7, 8, 9, 10. So here there is no common element in set A and set B. If there is no common element in two or more sets, the sets are said to be disjoint sets and their intersection A intersection B, there is no common element, is a empty set, symbol of empty. So intersection of two disjoint set is empty sets. Practice set 1.4. First example, if a number of element in set A is 15, number of element in set A in B is equal to 29, number of elements in A intersection B is equal to 7, find number of element in set B. So we know the formula, number of element in A union B is equal to number of element in A plus number of element in set B minus number of element in set A intersection B. Using this formula, we will find the number of element in set B. So here it is given that number of element in A union B is equal to 29. So 29 number of element in A union B. So next is equal to Na, number of element in set A is equal to 15 plus number of element in B set B, we have to find, minus number of element in A intersection B, which is equal to 7. Therefore 29 is equal to 15 minus 7 is equal to 8 plus number of element in set B. Therefore number of element in set B is equal to 29. 8 will get subtracted from 29 minus 8. Therefore number of element in set B is equal to 29 minus 8, which is equal to 21. Second example, in a hostel there are 125 students, out of which 80 drinks tea, 60 drink coffee and 20 drinks both tea and coffee. Find the number of students who do not drink tea or coffee. So let us assume that total number of students, that is NU, universal set, total number of students in the class B in the hostel B 125, NU is equal to 125 be the universal set of all students in the hostel. Let number of students drinking tea be Na, that is Na is equal to 80, which is given, and the all students drinking coffee be NB, number of students drinking tea be NB is equal to 60, and the students who drinks both tea and coffee are, that is common intersection is N, A intersection B is equal to 20. So we will find here the union, the students who either drink tea or coffee or both. So that is, first we will find A union B. You know the formula is equal to number of element in set A plus number of students who are drinking coffee minus number of students who are those who are drinking tea and coffee, that is intersection A intersection B. So therefore N A union B is equal to Na, which is given 80 student drinking tea, number of student drinking coffee is equal to 60 minus number of student who drink both tea and coffee are 20. Therefore number of student who drink tea, either tea or coffee or both, here are in the union. So 180 plus 60 is equal to 140 minus 20, which is equal to 140 minus 20 is equal to 120. Now this A union B means the students who either drink tea or coffee or both are 120 students in all. Here you have to find the number of students who do not drink tea or coffee. So here we have to find number of students who do not drink tea or coffee. So the number of students number of students who do not drink either tea or coffee is equal to total number of students, that is number of student universal set, minus number of students in A union B who either drink either tea or coffee or both. The number of element in universal set, total number of students in the hostel is 125, minus number of students in A union B is equal to 120. So the number of students who do not drink tea or coffee, 125 minus 120, that is 5 students. Third example, in a competitive exam, 50 students passed in English, 60 students passed in mathematics, and 40 students passed in both the subjects. None of them failed in both the subjects. Find total number of students. So let us assume that let E denotes number of students who passed in English, that is 50 number of students who passed in English, and denotes number of students passed in mathematics, which is equal to 60, and number of students those who passed in both English and maths, B, that is N A intersection B is equal to. So here we have to find number of students those who passed either in maths or English, that we have to find E union M, that is total number of students who either passed in maths or English. So we have the formula, number of students those who passed either in maths or English, that is N E union M is equal to number of students who passed in English and E number of students who passed in mathematics, and M minus number of students who passed in both the subject, that is N E intersection M. So here number of students those who passed in English are 50 and maths 60, and intersection they are 40 students. So putting the value below, NA is equal to 50 students plus NN is given as 60 minus both the subject, those students who passed are 40. So total number of students will be 110 minus 40, that is equal to N E union M is equal to 110 minus 40 is equal to 70, that is total number of students are 70 who either passed, total number of students who either passed in maths or science are 70. For the example, a survey was conducted to know the hobby of 220 students of class 9, out of which 130 students informed about their hobby as rock climbing, 180 students informed about their hobby as skywatch. There are 110 students who follow both the hobbies. Then how many students do not have any of the two hobbies? Then how many of them follow the hobby of rock climbing only? And how many students follow the hobby of skywatch only? So here the example, let us assume n number of students having rock climbing, that is NR is equal to 130. Then number of students who has hobby of skywatch, that is NS is equal to 180. Then total number of students, that is universal set, that is number of students in U, be 220 students in class 9. The number of students, those who have hobby of both rock climbing and skywatch, are 110 students. So here we have to find number of students having either of one of the hobby, that is R union S number of students is equal to NR plus ns minus n r intersection of s is equal to number of students having the hobby of rock climbing is 130 plus number of students having the hobby of skywatch 180 minus number of students having hobby of both, that is 110 r intersection s here, which is equal to 130 plus 180, which is equal to 310 minus 110. So number of students having the hobby of either one of the hobby or both are, that is 200 students. Now here we have to first find number of students having both the hobbies. So number of students having both the hobbies. So the number of students not having both the hobbies is equal to total number of students minus the number of students having either of two hobbies. So that is total number of students are 220 minus number of students having both the hobbies, either of it is 200. So 220 minus 200 is equal to 20 students. Next is the number of students having a rock climbing hobby is total number of students which are having hobby of rock climbing is 130 minus 130 minus the number of students having both the hobbies, which is equal to 110. That is 130 minus 110, which is equal to 20 students. And last, the number of students having only sky watch hobby is equal to the number of students having the head of sky watch is 180. 180 minus number of students having both the hobbies is equal to 110, which is equal to 70 students. So the answer of this example is 20 students do not have any of the hobby, and 20 students only have the hobby of rock climbing, and 70 students have hobby of skywatch. Fifth example, observe the Venn diagram and write the following sets. So observe the given Venn diagram carefully and write down the sets. So first is set A. So set A here is the circle. The element present in this set A are X, Z, Y, M and N. So write the set A X, in which X, Y, Z, M and N. These elements are present in the set A. Now second is set B. Set B, the elements contained in this circle are all elements of set B, which are P, Q, R and M and N. So in set B, the elements present are P, Q, R, M and N. Now elements present in set A union B. Elements present in set A union B means all elements of set A, all elements of set B, including this common element. So elements of set A are X, Y, Z, then M and N are the common element in A and B, and remaining element of B are P, Q and R. So these many elements are elements of set A union B. Now the elements present in set U. The elements present in set U is the all elements present in this rectangular box. In set elements of set A, B as well as this S and T. So all elements, that is X, Y, Z, element of A, then B, P, Q, R, and elements outside the set A and T, that is S and T. All elements are present in U. Now element present in A dash, that is A complement means elements which are there in A will not be in the A complement. So whatever elements are there outside this circle A, this circle are the elements of set A dash complement. So which are the element S, T, P, Q and R. So elements outside the A, S, T, P, Q and R are in A complement. Now B complement. Elements of B complement, the elements which are not in B but which are in U. Whatever elements outside this circle, that is set B, outside set B are elements of set B complement. That is elements are here first S, T and elements of A, X, Y and Z. These are elements present in the B complement. Now one more set, the elements, common element A intersection B. The common element in set A and B, this is the common part which is called as intersection A intersection B. So this A intersection B equal to the elements, only two elements are present in A intersection B, that is M and